Assalamu alaikum dear students. Today we are going to start a new chapter which is chapter number 11, that is conic sections. So firstly let us define what are the conic sections. If we consider a vertical line which is fixed, that is this line L, and consider another line, that is line M, this line M, such that this line is intersecting the fixed line, that is fixed vertical line at point V, making an angle alpha with this line. Now rotate this very line, this line M, in such a way that this alpha remains constant throughout. That is, if we consider two lines intersecting each other at angle suppose 30°, then if we rotate one of the line, non-vertical line, in such a way that while rotating this line, this angle remains fixed, that is 30°, this means that alpha should remain constant, then this generates a surface which is simply called as the right circular cone or double napped right circular cone, like this. Now in this cone, that is right circular cone, we have two naps. This is the upper nap and second one is this lower nap. The line M here, that is this line, this is called as the generator of this right circular cone. A right circular means that this vertical line here, it is axis, that is this axis, the fixed line which is called axis, is perpendicular to the surface, of this earth, or simply to the perpendicular to the plane, or simply the vertical line. Now the point where these two lines intersect is called as the vertex of this right circular cone. Now if we take another surface, that is plane, such that we intersect this plane with this right circular cone, then this generates a curve, or the curve is obtained. Such very curve is called as the conic section. Conic section simply means the part of the cone which is obtained or formed when the plane intersects this right circular cone. So let's assume that this plane intersects this right circular cone at an angle of beta, that is the angle between the plane and this axis of this cone is beta. Now on the basis of this alpha and beta, we will classify these conic sections as. Now first one is, if beta is 90, that is when the plane, this plane is parallel to the surface of suppose earth, that is this very, here beta is 90 because the angle between this axis and this plane is 90°. Now this, on intersecting this, we get a structure like this, that is it cuts it into two parts, that is this part and this part. Now here the intersecting portion is called as the conic section, and it is nothing but it is the circle. So circle is the conic section which is obtained when the plane intersects the right circular cone at an angle of 90°. Now if in the second case, if beta equals to alpha, now when beta equals to alpha, this means that this plane, let's assume that this plane, it will cross through the circular portion either from this nap or from this nap. So if it crosses through this, it means that it will cross only through this but not through this circular portion of the lower nap. This means that the intersecting portion or the resultant is the structure like this, which is a curve which is simply a parabola. So parabola is obtained when this beta equals to alpha while intersecting surface and the right circular cone. Now in case third, now if alpha is less than beta and both are less than 90°, when both are less than 90° and alpha is less than beta, this means that if alpha is 30, beta is 45. Now the plane, suppose in upper nap, the plane is intersecting like this and the surface generated is or this conic section obtained is of the form of this. So here this is not the circular, but it is elliptical in nature. So hence in this way ellipse is formed. So this means that the ellipse is that conic section which is obtained when the angle between the surface and the axis of cone is greater than the alpha and both are less than 90. The fourth case is when the intersecting plane, this plane intersects both the naps, that is this nap and this nap. This is only possible when beta is less than alpha, that the angle between the surface and this axis is less than the alpha. Then we get the structure like this. From upper nap we get this, and from lower nap we get the conic section like this. This whole conic section is simply called as the hyperbola. Now you know that in these four cases this plane does not cross through this vertex. Now when it does not cross through the vertex and restricting, taking the constraints as we defined in these four cases, these surfaces generated are called as the non-degenerated conic sections. But when it passes through this vertex, then those conic sections obtained or formed are simply called as the degenerated conic sections. Like if we consider beta equals to 90 and the plane passes through this vertex, then it simply cuts it at this vertex, because the intersecting point is only this vertex, which implies that the conic section obtained is this point. This means that this point is the degenerated case of this parabola. Similarly, if beta equals to alpha, in non-degenerate case beta equals to alpha is the parabola, but when beta equals to alpha, this means that it will intersect it at the line. It will intersect, or the resultant conic section obtained is the straight line. This means that straight line is the degenerated case of this parabola. Similarly, if beta is less than alpha, then we get two straight lines, which is a degenerated case of hyperbola. So this means that degenerated case of hyperbola is the pair of intersecting straight lines. For ellipse we simply get the straight line. So this means that for parabola and ellipse the degenerated cases are straight line, while as for hyperbola the degenerated case is the pair of straight line, intersecting pair of straight lines. Now inshallah in tomorrow's video lecture we will discuss these four non-degenerated cases, that is circle, parabola, ellipse and this hyperbola, one by one, and we'll do problems on these four conic sections. So thank you.